It really sounds like something out of a sci-fi movie, but I promise you, it's real. Right now, our entire digital world is under a constant invisible attack from the deepest, darkest corners of the cosmos.
Picture this, an Airbus A330 is cruising along and then suddenly it just pitches down, hard. Passengers are thrown against the ceiling.
Or how about this? A speedrunner is playing Super Mario 64 and then bam, Mario just teleports to a higher platform. It's a move nobody can explain, let alone replicate.
And then there's this one. A local election in Belgium gets thrown into total chaos by a result that is, get this, mathematically impossible.
So, a plane dive bombing, a video game glitching, an election going haywire, what in the world connects all of these? Well, they are not random. They're all linked by the same bizarre, incredibly powerful force. And to figure it out, we've got to go back and solve the mystery that started it all, with a single, unassuming voting machine.
Okay, so let's set the scene. The date is May 18th, 2003. We're in a place called Schaerbeek in Brussels, Belgium. And a single tiny computer glitch is about to threaten the entire democratic process.
So, they were using this electronic voting system that was supposed to be totally solid. You make your choice on a screen, and that vote gets saved in two places, on the computer's hard drive and on a magnetic card as a physical backup. A fail-safe, right? But as they started counting the votes, something really weird happened. A candidate nobody really knew, 𝗵𝘃𝗲𝗰, got a number of votes that, well, it was impossible. The system just couldn't produce that number. So, of course, they went straight to the backups.
Okay, so after hours and hours of recounting every single one of those magnetic cards, they found it. The original computer count for this one candidate was exactly 4,096 votes higher than the physical backup cards showed. It was like 4,096 ghost votes just appeared out of thin air. The big question was, how?
Well, the investigators were completely stumped. They went through the software line by line. Nothing. No bugs. They tested the actual voting machine again and again and again, and it worked perfectly every single time. As far as they could tell, the machine was flawless. So what gives? This left only one very, very weird explanation. And funny enough, the biggest clue was in the number itself.
Right, that number, 4,096. To us, it's just a number. But in binary, the language of computers, just ones and zeros, that number is really special. See, to add exactly 4,096 votes, you don't need some complex software bug. All you need is for one single bit of memory, just one little zero, to spontaneously flip into a 1. That's it. It's called a bit flip. But what on earth could cause a single bit to just change its mind like that?
This idea wasn't totally new. Way back in the 70s, Intel had this bizarre problem where their memory chips were having random bit flips. The cause? Tiny trace amounts of radioactive uranium in the chip's packaging were literally shooting off little particles and messing with the bits. The industry fixed this pretty quick by using super clean materials. So the Belgian voting machine, it shouldn't have had this problem, which meant the culprit wasn't inside the computer at all. No, it came from way, way further away.
So the investigation had to look up. Not at the software, not at the hardware, but literally up to the stars.
This part of the story actually starts over 100 years ago. Scientists back then figured that radiation came from rocks and soil here on Earth. So they thought the higher up you go, the less radiation you should find. Makes sense, right? Well, in 1912, a physicist named Victor Hess decided to test this. He took a radiation detector up in a hydrogen balloon, and what he found was the exact opposite. The higher he went, the stronger the radiation got. He had just discovered that our planet is constantly being bombarded by radiation from deep space.
So these things he found were called cosmic rays, but they're not really rays like light or X-rays. They're actual particles, mostly protons and atomic nuclei, that have been launched across the universe by insane events like exploding stars, supernovae, and black holes. And they're traveling at nearly the speed of light. I mean, these things are incredibly powerful. In 1991, scientists detected a single particle, they nicknamed it the OMG particle, that had the same kinetic energy as a baseball flying at 100 kilometers an hour, a single subatomic particle. Now, these primary particles from space almost never make it all the way down to us. Instead, they slam into molecules high up in our atmosphere, and that collision sets off this massive chain reaction, creating a cascade, a shower of millions of secondary particles, things like neutrons, that are constantly raining down on the surface of the Earth right now. Okay, so here's where it all comes together. The final conclusion of the investigation was this. One of those neutrons, created by a star that exploded maybe millions of years ago, traveled across the cosmos, hit our atmosphere, rained down on Brussels, went right through the roof of the polling station, and just happened to strike a single transistor inside that voting machine, flipping one bit from a 0 to a 1 and creating 4,096 ghost votes. Mystery solved.
I know, that sounds like a 1 in a trillion shot, right? But the crazy thing is, these cosmic ray strikes, what scientists call single event upsets, they're happening all the time. And the consequences, well, they range from just plain bizarre to absolutely terrifying. Okay, let's go back to that Mario glitch. It's now pretty much accepted that it was caused by a cosmic ray. A single particle hit the Nintendo 64 console's memory and flipped just one bit. And that one bit happened to control Mario's height value in the game. That tiny change made the game think he was suddenly on a higher platform, so poof, he teleported. The glitch was so impossibly rare that a $1,000 bounty for anyone who could replicate it went unclaimed for years.
But it's not all fun and games. The stakes can get much, much higher. On October 7, 2008, Qantas Flight 72 was cruising at 37,000 feet when the unthinkable happened.
Okay, so the plane has a critical flight computer called an ADRU. It handles all the key data, like altitude and its angle of attack. The official investigation found that the most likely cause was a bit flip from a cosmic ray. This little error caused the computer to misread its own altitude data as if it were angle of attack data. So the plane's brain thought it was in a deadly stall, and to fix it, it pitched the nose down, violently. It did this twice. In the end, 119 people were injured, all because of a single, random particle from outer space. So if we can't stop these cosmic rays, and we can't, how do we protect our most important systems from them? Well, luckily, engineers have come up with some pretty clever ways to fight back.
For starters, we can use special hardware. A lot of critical systems, like data servers, use something called ECC memory. That stands for error correction code. It can actually detect and fix these single-bit errors on the fly. For stuff that's even more critical, like the space shuttle, they used redundancy. They had 4 identical computers all running the same calculations. And if one of them got hit by a cosmic ray and gave a weird answer, the other 3 would just outvote it. And in some really high-tech facilities, they even use physical shielding and special software to protect their systems.
And this is a perfect way to understand the trade-off here. Think about your laptop. It's incredibly powerful, right? But it's also really vulnerable to this kind of radiation. Now compare that to the computer on the Mars Perseverance rover. That thing has the processing power of a smartphone from like 20 years ago. But its entire design, the materials, the circuits, it's all radiation hardened. It's built from the ground up to withstand the constant, intense bombardment of cosmic rays you get when you don't have Earth's atmosphere to protect you.
So it's pretty clear, right? These particles from deep space are constantly messing with the code that runs our world, flipping ones to zeros and back again, and we have to constantly engineer our way around the chaos. And that brings me to one final, really fascinating thought. If these cosmic rays can alter the ones and zeros in our technology, what might they be doing to the code in our own DNA? I mean, think about it. If these cosmic messengers can rewrite the digital code in our machines, what role have they played over billions of years in rewriting the genetic code of life itself? It's a pretty humbling thought that the same cosmic chaos that crashes our computers might also be one of the fundamental engines of evolution.